Okay, let's discuss note cards 33 and 34. The first one is 33, remainder and factor theorem. What we're talking about, it says when a polynomial is divided by x minus c. And we're talking about synthetic division. So if we're divided by x minus c, which is when we're using synthetic division, then f of c is the remainder, okay? If the remainder is 0, then c is a root or 0 of the polynomial, and x minus c is a factor of the polynomial. Now the reason why I mentioned synthetic division here is because there's two ways of determining what your remainder of a polynomial is going to be. You can use synthetic division, and if you use synthetic division, if your remainder is 0, then that thing that you're dividing by is a root. If you could also just evaluate the function at f of c, and if it is 0, then c, this piece right here, is again, it's still a root. So there's two ways of determining what your remainder is of this polynomial. You could use synthetic division, or you could use evaluate the function at c. So this first example, we want to divide x to the fourth plus 2x to the third minus x squared plus 3x minus 2. We want to divide that by x plus 1. So the first thing that we would have to do is set x plus 1 equal to 0 and solve for x, and we get that x is equal to negative 1. And then we can start our synthetic division over here. We've got negative 1. We have our coefficients in descending order here. And then the first step would be to bring down the leading coefficient 1 and then multiply. Negative 1 times 1 is negative 1. That goes here. And then you combine these two. 2 and negative 1 yields a positive 1. And then negative 1 times 1 is negative 1. And then when you combine these two, you get a negative 2. And then negative 1 times negative 2 is positive 2. And when you combine these, you get 5. And then you do negative 1 times 5 is negative 5, and when you combine these two, you get negative 7. So our remainder here is negative 7, and we found that by doing synthetic division. However, there's another way. You could have evaluated this function, f of x, at x, or we're calling it c in this note card, at c equals negative 1, and when you do that, you get negative 7. So you can find your remainder either way. Now the reason it's important to find the remainder is because we're going to be finding all of the roots of a polynomial. Maybe it's a 4th degree polynomial like this one. Maybe it's a 6th degree polynomial. And we cannot just find the roots by factoring. What we want to do is we want to start out factoring, and I'm kind of leading into note card 34 now. If we want to find all of the roots, then we would start off by, if we had something like this, x to the 4th, we couldn't just factor this out. So we would start out, if we're given one root, we would start out using synthetic division. Now remember, if we're using synthetic division, like in this case, if I started out with an x to the 4th polynomial, and I divided out an x term, down here what I'm left with is an x to the 3 polynomial. So this would have been x to the 3rd plus x squared minus 2x plus 5. And then of course you have your remainder, this minus 7 over x plus 1. But if you didn't have a remainder, like in this next example, let me pull this one up. In example 2, we end up with a remainder of 0. So if the remainder is 0, what that tells us is that this x equals 1 is a solution or a root. So it says here that x equals 1 is a 0 of the polynomial because the remainder is 0. So now I have, if I go back really quick, if I have 2x to the 3rd, the power of 3 is the highest exponent, that means I have 3 solutions here. How can I find those three solutions? Well, I can find one if my remainder is 0. I know that what I divided by is a root or a solution. So here I have x equals 1 is a solution, so I know that's one of them. I have two more. And if I have x to the third here, this one becomes x squared. So here I have 2x squared plus x plus 3 equals 0 as a quadratic. And how I would go from here is to find the remaining two roots, because there's two left, is I would either factor this or use the quadratic formula. So the important thing from note card 3, and I kind of mixed 33, and I kind of mixed note card 33 and 34 together a little bit here. But the main thing you need to take away from note card 33 is this. Using synthetic division, if your remainder is 0, what you divided by is a solution. Okay? And if you use f of that number, that can also tell you the remainder too. And if that remainder is 0, then c, if I do f of c, and if this is equal to 0, then c is a solution. Those are the main two things you need to take away from note card 33. Now in note card 34, let's just look at an example that'll tell us all about note card 34. This is example 1 for note card 34. And so, if I gave you this problem on a homework assignment, a quiz, or a test, I would ask you to, well, it's also going to be given to you one root for now. After today, you will be having to find roots possibly, but today you're going to be given at least one root. And so the directions might say, given at least one root, find the remaining roots or solutions to the polynomial. And so what you would want to do is, first, you might need to determine if this is a root. How do we determine if this is a root? Well, we could do synthetic division, and if the remainder is 0, then 8 is definitely a root. Or I could do f of 8 here, and if it's 0, then 8 is definitely a root. So I would begin with, I'm going to choose synthetic division. So I'm going to start with this. Bring my leading coefficient down. 8 times 1 is 8. Negative 4 plus 8 is positive 4. 8 times 4 is 32. Negative 44 plus 32 is negative 12. 8 times negative 12 is negative 96. Combine these two and I get a 0. So it's confirmed that 8 is a root or a solution because my remainder is 0. But I need 3 solutions because I have the highest power of 3. So I have 2 remaining solutions. Well, if I started off with the cubic, what I have left after synthetic division is a quadratic. So I have x squared plus 4x minus 12 equals 0. How can I find these last two? Well, I'm going to first try to factor because that's the easiest way. So if I break this down and do a complete review of factoring again, a is 1, b is 4, c is negative 12. Signs are going to be different. The biggest one is positive. Look at my a times c is negative 12. I don't have to worry about this negative sign because my signs are taken care of up here. Look at my factors of 12, which is 12 times 1, 6 times 2, 4 times 3. And if my biggest one's positive, that implies the smaller one is negative because the signs are different. Which 2 adds to positive 4? And it's these two, the positive 6 and the negative 2. Next step is to divide by a, which is 1. And x goes with the number on bottom, so it's x plus 6. And x minus 2 equals 0. Set each factor equal to 0 to get what x actually is, or the solutions. And I get that x is also not just 8, but it is negative 6 and positive 2. Now you're not only going to be needing to give the solutions, but you're also going to want to write this polynomial in factored form. And the way you do that is you have two parts right here, x plus 6, x minus 2, and you also have x minus 8. Change the sign on the solution, and this would be factored form. And that's one example of how to use the remainder theorem, given at least one root, finding all of the roots of the polynomial. Let's look at one more example for note card 34. Example 2. And you are told that x equal 1 is a double root. Now what that means is that that's going to be counted twice. So we have a total of 4 solutions we're looking for here. We already have 2. So I'm going to begin with synthetic division, dividing by 1, which is the root that I know. I'm missing an x squared term, so I must put a 0 in its place. And then begin my synthetic division. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. Negative 2 plus 2 is negative 5. 1 times negative 5 is negative 5. Combine those, I get 0. That verifies that 1 is a root here. What I'm left with, because I had an x to the 4th, is x to the 3rd plus 2x squared plus 2x minus 5 equals 0. I still have 3 roots remaining because this is x to the 3rd, but I'm given a second root up here. When I'm given a second root, I can do synthetic division again with my remaining polynomial. I can divide this again by 1. So I do synthetic division again with 1, and I use this polynomial now. 1, 2, 2, negative 5. Bring down the leading coefficient. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 2 plus 3 is 5. 1 times 5 is 5. Negative 5 plus 5 is 0. Remainder is 0 again. Confirms that yes, these are roots. But more importantly, I'm left with a quadratic. X squared plus 3x plus 5 equals 0. So I can find my remaining 2 roots with this quadratic, either by factoring or the quadratic formula. You're going to find here that x squared plus 3x plus 5 is not factorable. So we must use the quadratic formula. So A is 1, B is 3, C is 5. Plug it in. Simplifying, I have negative 3 plus or minus. 3 squared is 9. Then I do all of this next. This is very important. You must multiply these 3 things together. You can't take 9 and subtract 4. That breaks the order of operations. So negative 4 times 1 is negative 4, and negative 4 times 5 is negative 20 over 2. Continuing to simplify, negative 3 plus or minus root negative 11 over 2, because 9 minus 20 is negative 11. Continuing to simplify, negative 3 plus or minus. You should see that square root of negative 1 underneath here pops out as the I, and I'm left with root 11 over 2. Now at this point, what I would do, this radical you can't simplify it any further. 11 is prime. But I would look at this number, and the number in front of the radical, which in this case is 1. And I would look at those three numbers and see if there is some type of a common factor other than 1 that I could divide and simplify by. I cannot here. I am done. And so here are my 4 solutions. 1 and 1 are 2 solutions. And then I have 2 more solutions here. I have negative 3 plus I root 11 over 2. And I have negative 3 minus I root 11 over 2. But when it comes in this form, when you're writing the solutions or the roots, when this is not factorable here, leave it the way it is. Okay? You don't have to write 2 solutions here. This represents 2 solutions. Now this is part of it, but the other part is to write it in factored form. When I'm writing this polynomial in factored form, I have 2 solutions here, so I have x minus 1 times x minus 1. And I also have this thing, x squared plus 3x plus 5. And that would be the factored form, because this is unfactorable. I would have to write it like this. A little bit more simplified would be x minus 1 squared, because there's 2 of them, and then x squared plus 3x plus 5. That's how this works. Remember to use synthetic division or f of c to find the remainder. If the remainder is 0, then that thing you divided by, or c, is a solution. And you can find the remaining solutions by either continuing with synthetic division or factoring or using the quadratic formula.